Hello YouTube and welcome to this amazing new video. Today I've got a very interesting piece of art for you. Actually it's this one over there. This is a giant 3D build of the logo that the National Aeronautics and Space Administration in the US is currently using. And in this video I'm going to show you exactly how I built this. But first, let me tell you a story why the idea came to my mind in the first time. So, I study electrical engineering. And in my free time I like to invent and just make stuff. NASA, like the organization itself, just stands for Innovation and Industry-Leading Engineering. Both of these topics are very interesting to me as an individual, because one day I want to contribute to that one as well. And to be honest, I think it just looks cool, and it does, especially at night, so let's have a look at that. So as you can see here, it just looks amazing in the dark. But another cool thing is that if this on and off fading of the individual stars is actually disturbing you, you can turn it to solid color. I have two buttons on the bottom side. The first one is for standby, and then it will turn everything off. And the second one is to switch between fading and solid mode. So now, let us have a look at how exactly I built this. So the first and also the easiest step of the whole build process is that you have to download an image editor software. It should be something that can handle vectorized images, for example a SVG file, because then you can select all the individual components and resize them all individually. For example, I wanted my big blue circle to be exactly 70 centimeters by 70 centimeters, and here this is done very easily without using any resolution. I don't know why Inkscape always adds these 0.070 centimeters, maybe someone can explain that. If you have a printer that is big enough to print this whole document in the desired size you want, so that you can use it as a template, then you're just set, okay, just fine, print it out and there you go. But most people don't have a printer that is big enough of printing a document that is, for example, 70 centimeters in diameter. So thankfully there's a solution for that. Export the whole project as a PDF file and open up Adobe Acrobat DC Reader. Inside of that, click on Print and then you can select Poster. The nice thing about that one is that if you select your printer, it will automatically slice the whole PDF into slices that your printer is capable of printing, and afterwards you can stick them together and continue. Because it's not that easy to cut out a perfectly round circle using only handheld tools, I came up with a small trick. So here I took a spare piece of wood that I mounted in the middle of the circle, and I attached my jigsaw onto it, and then when you move the piece of wood around, you actually are able to cut a perfect circle. After that you only have to paint the whole circle and then you're done with your background. It's as easy as that. Unfortunately, the hypersonic wing is a little bit more difficult to build, because as you can see here, for example, the S has to go above the upper part of the wing and below the lower part of the wing. So this is why we are building our wing in two pieces, so that later on it's easier to stick the S in between. I found the easiest way to actually transfer your template onto the wood is by using a very new marker. And then you just go step by step and stop for a small time. And when you do that, the ink actually transfers from the template onto the wood, and later on you have a nice line so that you know where to cut. After we have done that, we can glue our two pieces together and use some wood filler to fill out the big gap between the upper and lower part. If you don't have some wood filler on hand, or if you're just silly, just like me, and don't want to buy something, then here's a nice trick for you. Don't throw away all that sawdust that you produced earlier and mix it up with some wood glue. This is a perfect wood filler, and once it's completely dry, you can easily sand it down. Yeah, so this is a very cheap solution. And also environmentally friendly, right? The next step is to sand everything down. Really take your time doing that, because in the end you want a mostly or as good as possible smooth surface, and this is also the reason why I applied even more wood filler in the end. If you're wondering why I painted the whole thing in green here, well, this is just another technique of filling up gaps in wood. And this is a very easy trick. You just paint the whole thing in multiple coatings, and by painting I mean really use lots of paint. Because in the end you want to have some substance that you can sand down so that you have a smooth surface. If after that process you're still left with some small gaps in the wood, just use an old candle and carefully drip the melted wax onto the surface. And once that has dried, you can use a spatula or like any other tool you want, maybe a ruler is also possible, just to scrape all the excess wax away. This technique is very easy, but unfortunately it's not suitable for everything, because not every paint is going to stick on this wax afterwards, so be careful doing that. Be sure to apply multiple coatings of red glossy paint, because if you apply too less, then in the end you won't have this very shiny surface. And to be honest, the shiny surface of this hypersonic wing here is one of my favorite parts of the complete build. If you wanted to do the lettering by hand, then this would be the most difficult part of the project. But because I have a 3D printer on hand, I just printed out all the letters. Be sure to check out the description for the STL files, so if you want to do that as well. Maybe it's a good idea to just sand them down a little bit, because most 3D printers they leave a more or less rough surface, and after that be sure to apply multiple coatings of paint as well, just like with the hypersonic wing, more is better. And now for the first time you can actually kind of see how the logo will look in the end, because everything is done and now it's time to check if all the sizes are correct. To do that, we can take another template and position all the components in the space where they belong, and if everything fits and the whole thing looks nice, I mean, yeah, that's a good point, you can continue then. To mount all the components to the base plate, we have to drill a few holes and also install some spacers. So for example, for the letters here, I used some spacers that are the same height as the height of the hypersonic wing. Once you're done with that and all the holes are drilled and all the spacers are installed, you can continue by actually aligning all the individual letters to one another, so that in the end they give a straight line. I used a scrap piece of wood for that, and just positioned my letters like this to see if everything would fit. After that was the case and I made sure that my piece of wood is actually in the right place, I grabbed some glue. In this case it's a T7000 glue from China, and Chinese products always surprise me. For example, this glue has a magic glue ability, but before you apply it, please check out the technical data at the back. So this is so silly. If you applied the glue, just firmly press on all the letters, and if everything is properly seated, be sure to unscrew everything and let it dry, and just put them away and let them dry. Once that is drying, we are focusing on another thing, and this is the wall mount. I have designed some special wall mount things that you can also print out on your 3D printer, or if you have another idea of mounting it, then this is fine as well. There is no risk of falling off or anything like that. Of course, please check that both your mounts are mounted at the same height and everything just fits fine. And then it may be a good idea to just test out if everything would fit on the wall and if it looks nice. To get all the stars to illuminate, of course, there has to be some way for the light to pass through. So this is why all over in the base plate you need to drill some very small holes so that you can stick an optical fiber through. I started with a very small 0.5mm drill bit and later on went bigger. Because unfortunately I first started to just put the optical fibers through and wanted to bundle them in a single spot, but unfortunately the super glue I used just melted all the fibers and it was a huge mess. So later on I sticked to the following method. Just imagine that this blue bar here is our base plate, and the upper side is the back and the lower side is the front. And the first thing we want to take is a 1.5 millimeter drill bit and drill all the way through the base plate. After that, we take a bigger drill, this time it's 3.5 millimeters, and drill about a half or a third through the base plate. Once that one is removed as well, we can continue by taking our optical fiber piece. This one is 1.5 millimeters in diameter, and the hole is also 1.5 millimeters in diameter, so it should be a very tight fit when you put it inside, but it should work. And but make sure that it's not all the way in, just let it stick a little bit out. Next, take your 3mm LED, and but before you insert that one, be sure to apply some glue into the groove. Just put a drop of super glue inside of that, and then using the force of the LED, just press it in and then press it all the way through. This way the glue gets spread evenly across the fiber and the LED as well, and everything will just stay in there. After you have repeated that 40 times for all the stars, it is finally time to turn the whole contraption upside down. And now it's time to paint the stars, so simply get yourself a really fine brush and some white acrylic paint. You can also put some little glitter inside if you want. So yeah, very carefully draw the stars, and after you have done that, you can trim off the excess fiber. Of course, I know the whole painting process is really tedious, but take your time with that. In the end, everyone is going to see that, and if you're done, then it looks really cool. I really don't want to go into too much detail about the electronics here. The schematic is in the description, and if you're interested, then just have a look at that. Basically, what you see here are 5 different circuits of LEDs that are all connected in parallel, and I tried to distribute all the members of each circuit across the whole plate, so that in the end, when I modulate the brightness of each circuit, it looks like the whole pattern is completely random. The heart of this electronic project is an Arduino Nano microcontroller, which is controlling all the individual LED circuits using N-channel MOSFETs, but have a look at the description for the schematics. And of course, don't forget to add all the buttons so that you can switch between continuous mode and also be able to turn your device on and off. So the IDE I used to program the whole thing is Visual Studio Code. Be sure to download that one, and also make sure that you have the Platform IO extension installed. So go to extensions, those are the four squares on the left side, and search for Platform IO IDE. After you have downloaded that one, reload the IDE, and then you can go on the little alien symbol on the left and click on Open, and open up the project you got from me. So after you have opened my project, you can check out the main.cpp file. This is the entry point for the whole program, but actually all the magic happens inside of NASA logo.header++. If you don't really understand what you see here, then just take your time and have a look at the code and try to understand it step by step. But basically there are a few things that maybe you're not interested in changing the program at all, maybe you just want to run it and that's it, but then there are a few parameters that you can change. The first one is the maximum LED brightness. You can choose between 0 to 255. This is the PWM duty cycle. 255 is the brightest setting for the LEDs, that means continuously on, and 0 means continuously off. So if the logo is too bright for you, just adjust the M-duty max value to a smaller one, but never go above 255. And the other thing is, if the flickering is too fast for you, then just adjust the M-period min and M-period max times. Those represent a millisecond time of the period that the LED is taking from one complete off, on again, and again completely off. Once you're satisfied with the code, you have to click on the little alien symbol again, and then just click on build, and then after that you click on upload, and that should work. If this is not working for you, then you have to check out that you have the correct drivers installed. Maybe you have an Arduino clone board from China, then you have to install some specific drivers, but this is something you can really ask Google and it will help you out, so no problem with that. Okay guys, that was it with this video. I hope you liked what you just saw, and if you did, then please share the video with your friends and click the little like button and also subscribe on the little bell. So, you know, just click all of them. And if you have any questions, have a look inside of the description. There are like all the code is inside of there and the electrical schematics and everything you need to know. And if you have another question, just post it into the comments. And if you're done with that, then check out my other videos and have a nice day.